So zinc weighs 65.39. I have two nitrogens, and they weigh 14.007 times 2. And I have 6 oxygens, because the 2 outside the parentheses affects everything inside the parentheses. So in this molecule, there's 1 zinc atom attached to 2 nitrates off to the side. So, and each nitrate has 3 oxygens. So that gives me a total of 6. Okay, I sum these up. So that's 65.39. This one is 28.0, you see 14.007 times 2, 28.014, and 6 times 16 is 96. Okay, so I add those all up. 96 plus 28.014 plus 65.39 for a grand total of 189.4, we'll round it to. Okay, what that tells me, I have 184.9 grams of zinc nitrate in 1 mole. So that number plugs in right here. Okay, 189.4. My moles cancel. I multiply across the top and divide up. 0.81 times 189.4 gives me 153.4 grams. Okay, because my moles canceled and now I'm in grams. So the original question, what mass of zinc nitrate is needed to prepare 675 mLs of a 1.2 molar solution? Okay, well the answer is 153.4 grams. And that's how you get there. You have to do 2 conversions. I had to convert, first I had to figure out how many moles of zinc nitrate are in 675 milliliters. Then I got to figure out how much that many moles weighs. So I came up with 0.81 moles, and then I had to figure out the weight using the molecular weight of zinc nitrate, zinc 2 nitrate. Okay, and that's how you solve one of those problems. The last type of problem that we see in Chapter 18 are dilution problems, where they'll give you a solution at a certain concentration and then they'll ask you to make up a solution from it at a lower concentration. So you're usually adding water to dilute it down, but you need to know how much. Okay, and the formula for that one, the second type, is M1 times V1 equals M2 times V2. So you've got the molarity of the first solution times the volume of the first solution is equal to the molarity of the final solution, after you've diluted it, times the volume of the final solution. Okay, so let me give you an example. It says hydrochloric acid is obtained commercially at a concentration of 12.1 molar. So when you buy hydrochloric acid, you get 12.1 molar stock solution. How many milliliters of 12.1 molar HCl must be used to prepare 2 times 10 to the third milliliters of a 0.5 molar HCl solution? Okay, so let's figure out what they're telling us here. So they're telling me that my molarity 1, that stock hydrochloric acid solution, is 12.1 molar. Okay? And they want to know how many milliliters of that does it take to make up this new solution. So that V1 is my unknown. That's what I'm solving for. And my final solution, or my end solution, my molarity 2 and volume 2, they're telling me I need 2,000 milliliters, that's my volume, of a 0.5 molar solution. Okay? So all I did was I took the word problem and I figured out my variables. What was my first molarity, my first volume, my second molarity, my second volume? Well, my volume that I need of that stock solution is the unknown. That's what I'm solving for. Okay, so to solve this, I would first multiply these two together. 0.5 times 2,000. And that gives you 1,000. Okay. And then, to isolate V1, I would divide the 12.1 over, and go ahead and divide 1,000 divided by 12.1. And my volume 1 that I need of that stock solution is 83.3 milliliters, because I was working in milliliters. And that's how you do a dilution problem, going from an original concentration to a weaker, more dilute concentration by sampling out of a stock bottle, adding water to it, and getting a new concentrated solution. Okay, let's try one more of those. Now this one says, how many milliliters of 18 molar sulfuric acid must be diluted with water to prepare 5 times 10 to the third milliliters of 0.25 molar sulfuric acid? So now we're working with sulfuric acid, and we buy the stock solution, and it comes to us in 18 molar strength. So that's our molarity one, 18. Okay, and it wants to know how much of that do we need to make up this 5,000 milliliters of this 0.25 molar solution. Well, that's our unknown then, our volume 1. That's what we need to figure out. How much of the stock solution do we need? Okay, well, they want me to make a 0.25 molar solution. So that's my ending molarity, my M2. Okay, and they want 5,000 mLs of it. Okay, so just like the last problem, I plug in the numbers from the word problem that they're giving me, and then I solve for the unknown, which is the volume of the stock solution that I need to dilute up to 5,000 milliliters. Okay, well, first I multiply these two together, 0.25 times 5,000. Gives me 1250. I bring over, because I want to isolate my V1, my 18, and I divide, and I get 69.4 milliliters, because I'm working in milliliters. And that's how much of that stock solution I need to start with, and then dilute it up to 5,000 milliliters, and I'll have my 0.25 molar sulfuric acid solution. And that's how you do dilution problems.